Hello, can you hear me?
Hi, Loa. Hi,
Hi.
everyone. I can
Uh,
hear you.
Actually, Meetek will get very, very silent if no one has the mics turned on.
Yeah, it's the
Uh,
opposite of WebEx. Everybody's muted until they unmute.
yeah. Hmm.
Okay, as usual, we are waiting a little bit for more people to join. And we are at 9 participants at the moment.
Stuart, do you remember if Andy said he was going to show up today?
Flag. Right. I vaguely remember him saying no, but I can't remember for
Yeah,
sure.
that's the same for me. I mean, that's why I asked. I, I think he said no.
And Matthew won't be here today because he's on holiday, I think.
Okay.
I think he'll wait till next week.
Okay, it's 10:06. We are 10 participants. We can wait one more minute, or if you think someone else will join. Andy, you said he's not.
Nick also said that he's a very, very strong maybe.
Usually Tony is on these calls, Tony Lee, but I don't see him. Yeah.
Tony joined later.
Oh, okay.
Yeah, because he definitely was in the discussion last meeting.
Okay, thank you, Greg. All right, Loa, I'm ready to start. I think this is about it. Some people might join after.
No, that's fine with me.
Okay, good. So welcome and thanks for joining, everyone. This is the second M&A interim that we're having. Yeah, I mean, maintaining the numbering may be a hassle. So we'll look into maybe keeping the date as a reference if we go out of sync on the numbering. But as usual, this interim is a joint meeting between three working groups, MPLS PALS and DetNet. And we have attendance from the three working groups at the moment. Okay, I'll move on. Since this is an interim, we have to remind everyone of the note 12. This session is being recorded. It's recorded and it'll be broadcast on YouTube and for anyone to see it after. The note 12 is the set of practices that or processes that govern our contributions, as well as the different processes in IETF. So I will leave it for you to go through them if you haven't already. Some useful pointers we are flashing every time. Blue sheets, you know that by now they're automatically generated and you can inspect them at any time after on the meeting materials page. And the rest of the pointers are for you to get easy access to this, to the material, basically. So today's agenda is up for bashing now. I think we have one slide here and another slide coming up. So this is the time to, bash it and sound your objection if you have any. The agenda is not heavy, but we will go sequentially over stuff. So this is the first slide for today's agenda, and we will talk more about PSD and some point that Stewart raised on the mail. And lastly, but not least, is any other business, if someone wants to add any item. Okay. I don't see anyone raising their hand, so I'll move on. Okay, before I move on, I'll go to the agenda to grab the first item there. So we talked about action items last time, and I was reviewing last time's request for actions. We had presented a set of questions. Those will come up again in the PSD discussion. A set of 5 questions that we're asking the attendees or the working group in general to get answers for. And this is one thing, an action item I'm tracking. We also had a request to get input for use cases that are relevant to PSD. So if someone has a strong use case for PSD and they want to present it again, please come forward and let us know, and then you will be on the agenda if you want to present the use case. Today we have one such use case, and Rakesh will be presenting it. But this is the second action item I'm tracking. I did not record any other action item from last time, so if you have any recollection of anything I missed, let me know. Okay, so that's item number 2 on today's agenda.
Eric, I'm in the queue.
Oh, I don't know.
You don't see
You're not
that.
raising your hand, though.
Okay.
Oh, you are. Sorry.
Yeah.
Somehow I did not see. Okay, Loa, go ahead.
So just a small kind of different view on what we actually asked for. We are not primarily asking for new use cases, though it might turn out to be new use cases. We are actually mostly asking for how the existing use cases actually responds to the questions we put up last time, and that's the important discussion we need to have. And that actually is the motivation for, do we need PSD or do we not need PSD? That's where we want to go. Thanks.
Okay, thank you, Loa. All right, so the next item on the agenda is the discussion on reclaiming label 14, and we have an update on that. Do you want to give the update, Loa, or you want me to give the update? I'm not sure. I can't remember.
You can do the update. I wasn't actually at the meeting at full time.
Okay, I also attended half of the meeting. Okay, so there was a discussion last time about a poll that we want to send to ITU. Right now, it's waiting to be finalized. There is a rough write-up being prepared, and actually in liaison that's being prepared to be sent to the ITU, so that we can ask if label 14 can be reclaimed. We don't have, the impressions we are getting is it's a hard process to get ITU to update their records, and get this label, a confirmation on the label to be reclaimed. So right now we have. Okay, maybe I'm not accurate. I'm trying to read through something is on hold. Loa, is it the liaison or a poll?
No, the
Maybe-
poll. Sorry. Yeah.
Go ahead.
The poll to the working group is on hold until we actually have the liaison and can send that.
Okay, that's clear now. Okay. Okay, so we're not going to send a poll until we send a liaison to ITU-T, but we have concerns at the moment that it's not going to be an easy process to reclaim the label 14, because it's primarily was allocated for ITU-T purposes. Okay, there's no additional feedback on this, and we can move on to the first nibble discussion. And why don't, Loa, you go ahead and talk about that?
You can move to the slide number 6, whichever it was. Yeah. So this is my take on where we are in the first nibble discussion. I kind of see 3 different cases. I don't see why not all of them could work. So we could allocate a unique value for M&A PSD, and then we require that the sender sets it and the receiver actually checks it on receipt. There is a uncertainty, or actually this method is unsafe, because all the packets that we can get into is not always, even if you find that unique value in the first nibble, is not certain that it is M&A PSD packet. So you need to have additional information carried in the packet to actually decide. And to my mind, that what is carried in the packet is enough to actually decide whether it's an M&A PSD packet or not. So the first nibble is kind of uncertain and unnecessary. We could also set the first nibble to 0 and pretty much do the same thing. I don't really see any real difference between these two, other than, and that's the third case, when you actually set it, you can ignore it on a receipt, but if someone else that is not M&A capable actually find that first nibble with the value we have allocated for M&A PSD, that it could be used to say that, okay, this is M&A PSD, I shouldn't do certain things to this. It could mean that you actually don't do those certain things to something else, but I don't think that is a catastrophe. So yeah, those are the three cases I see. I don't have a real strong preferences, but we need to actually decide among them. Okay.
We have
thanks.
someone in the queue, Loa.
Yeah.
We have
Yeah, we have
Tony.
Tony in the queue, yeah.
So I disagree that the first nibble is unsafe. You know, if we really don't feel that it's trustworthy and we don't want to make it into actually a demux point, then what's the point of the first nibble draft? You know, if it's just a random number, you know, that's what it is. So our position is somewhat self-contradictory, I think.
Okay, thank you. Joel, you're next.
I should probably just let Greg defend his draft, but I think there's good reasons for the first nibble draft. We know that there are things which make use of the first nibble in heuristic fashions, and the first nibble draft documents what we know about that first nibble so that if people insist on using heuristics, they can do so. Making it a well-defined demux point would be a very, very different proposition, and I think is a bad idea.
Mm-hmm. Greg, you're next.
Well said. Thank you.
I can't hear you. Okay, you dropped off, Greg.
Concur with Joe.
Okay,
So,
I see.
There have been misunderstandings, and I've been part of that before. So clarifying this, setting a registry, putting text in the document so that it preserved as for the community. I think it's a good use of the document. So that's the purpose. But again, their main purpose of first nibble is to differentiate from IPv4, IPv6 traffic, as there seem to be legacy systems that use it for load balancing or some other operations, some heuristics.
Okay, so that's well and good, and the draft makes sense. But if you think that turning it into a demux point is a bad idea, could you say more about why it's a bad idea?
because we have a limited number of points. So
We always have a limited number of points. All fields are finite.
yeah, but you know, if we made some mistakes, why repeat them?
So we're going to continue to make the mistake and reuse 0 for everything.
No, we evaluate case by case, and we decide as a community what makes sense.
Okay, well, I agree to disagree.
Thank you.
Okay, I'm next. I was gonna say that if it was the case, then 0 would be enough to differentiate from 4 and 6. But unfortunately, there are multiple applications that have started to assign values. One from the top of my mind is beer and .NET, I believe, if I'm not mistaken. So they're assigning values for the first nibble. I'm not clear why they chose to do that versus 0. So if someone has the, maybe we need to investigate why they chose to use the specific value other than 0. But the argument that you could use 0 only is not holding today. Thank you. Loa, you're next.
So I try to explain what I'm thinking about this. The value it could for M&A PSD. And then you receive a packet and you only use the first nibble as a DMAX point. You cannot be certain that anything that has the number we assigned is a M&A PSD packet. So it could be, for example, a Ethernet pseudowire without a control word, and you can't differentiate that on the first nibble alone. On the other hand, if you actually go into the stack and look at the bits said to tell this that this is an M&A PSD packet, that information is very strict and very easy to understand and actually give you the right answer. So you don't need to look at the first nibble. That's where I come from. Thanks.
So the first nibble does actually have a semantic. I believe the semantic is this is not IP. That was the originally intended semantic for it, for sure. And it is distinguished in the first time we used this in MPLS, which was on pseudowires. That was distinguished from 1, which had another semantic within the context of the pseudowire label, i.e. the service label. .NET, I thought from memory, used 0. I certainly was deeply involved in the design. I don't remember it using anything other than 0. I don't remember any discussion about a value other than 0. So I'm pretty certain that .NET actually uses 0. I do not know why Beer used something else, and I think maybe we should ask Beer why they did it and try and understand whether what they're doing with it is actually safe. But I don't think it's safe to make any assumption, certainly in a P router. It's not safe to make any assumption about the post-stack information of whatever sort without having the context of the label stack telling you explicitly. Thank you.
Thank you. Greg, you're back. You're at the top of the queue. Go ahead.
I think that Stuart already clarified that .NET effectively uses 0 and 1 first nibble, so analogous to pseudowire. control word is 0, first nibble, and ACH, the DetNet ACH is 1. So DetNet is not trespasser. Thank you.
So I'll
Go
go.
ahead. Go ahead.
I think maybe someone who knows about beer should explain why beer used a value other than 0 or 1. And are there any others? Can anyone remember?
I believe in the draft, Stuart, you had composed or compiled most of the values, but
Yeah, I can't remember whether there's anything other than DetNet, pseudowire, and IP, of course, and beer. Are there any other protocols we need to consider?
As we pointed in
I can't remember. That's all.
As we pointed out in the latest update of first nibble draft, NSH. So it's a SFC NSH plays interesting trick with the first nibble, and that might result at some point in the future in first nibble after MPLS label stack to be some other value.
Okay, Joel, you're at the top of the queue. Go ahead.
Just to clarify, NSH's use of that first nibble is not for demux. NSH assumes
Correct.
that you have other means of knowing that NSH is present. It was merely to avoid accidental confusion that we went with a different value. It was not for demux. Thank you.
Yes. Thank you, Joe.
Okay, maybe that point at the end, it was used to eliminate confusion. I think this is what one of the bullets there is trying to achieve, is to not use it to demux, but if you can clarify further, Joel, what did you mean by eliminate confusion? Thanks.
So it was pointed out in the SFC working group that in principle, because of the way it can be carried, NSH could follow an MPLS label stack. That's perfectly allowed. There's even, I think now, RFCs that tell you how to do it. So we wanted to make sure that it didn't get confused with value 4 or 6. And since there were spare nibble values, we used a value other than 0. But frankly, in retrospect, we probably could have just used 0. But at the time, we were also trying to say, well, if you care, you're not going to, if you're doing some more complicated heuristic, you're not going to think it's something else. But I don't think anybody made use of that aspect.
Thank you. Loa, you're next.
Now you can hear me.
Yeah.
I think that the bullet number 3 is very close to what the SOC are doing. You prescribe to put a certain value in there, but you don't need to check it when you receive a packet. And if someone else sees it, it could draw some conclusions. Given that you can't distinguish it on the first nibble only from a Ethernet pseudo-wire without a control word that has the same value in the first nibble. And that's what I mean. But that's what I mean when I say it's unsafe.
Okay. Stuart is next.
I am not quite so confident that we won't ever want to do a demux on this. So, I mean, I'll give you an example. We probably should have been wiser at the time. When we designed pseudowire, we didn't anticipate that we would need an OAM because OAM wasn't quite so popular in those days. And we needed a demux, which is why we introduced one. So I would be fairly cautious about asserting that we would only ever need one value. You don't know whether you will need to do some form of demux within the protocol on that first nibble. So I think I would not assert or not pick a number and say that no other number will ever be needed.
Okay, Jags, you are next.
Yeah, I have a question. After NSH discussion, right? So can NSH coexist with the MNA header or not?
Yeah, that's a good question. So we discussed coexistence in one of the use cases of existing MPLS features. And NSH in MPLS is one existing feature. The solution is yet to be drawn, I think, or to be put forward. But the use case was in use cases draft. But I'll see if anyone wants to comment on the solution perspective.
I'm next, I think, and I don't remember seeing any serious discussion about how we would make it work. Certainly, it's not been one of the ones that immediately sprang to mind. So we should add it to the list of of interactions that we need to be conscious of, together with pseudowires, DetNet, and Beer.
Correct. Loa, you're back.
I kind of agreeing with Stuart that, okay, we could demux, but this is not the demux between any value of the first label. That's an demux within the M&A protocol. So you need to go to the stack, decide that this is M&A PSD, and then you go look what the value is. And if we at that time actually assigned a second value for M&A PSD, we can do the demaxing within the protocol, but it's not a general demux.
I agree.
So I didn't understand the general demux story. We already have a in-stack M&A label which carries, this is what's in the post stack, or maybe there is something in the post stack. Why do we need further first nibble? Yeah, maybe you can clarify.
So first of all, in the terms of general demux, which I think, and Tony, correct me if I don't understand him properly, I think Tony is trying to have a world where he can go straight to the bottom of stack and take actions based solely on that first nibble. And a number of us are saying we don't believe that to be safe, and we're saying that based on stuff we know is in the wild. In terms of what I think demux is concerned within the protocol, it may be that we wish to create some other construct, just as we in pseudowires decided to create the ACH, and that first nibble is a good way of demultiplexing within the context provided by the label stack to that point. So you would know that you were from the label stack that you had PSD. You go down and process the PSD, and it may be that in the fullness of time we decide we need to add a feature that needs to stand out on its own at the first nibble, rather than be buried inside the actions in the post stack data. OAM was a good one. So supposing we wanted to do some instrumentation of the handling of of this work, then you might decide to put a demux at that point. Others can go ahead.
Okay, thank you, Stewart. Loa? You're next, Loa. Okay, you dropped off.
Yeah, I forgot to take my hand down before.
Okay, Tony, it's back to you.
Stuart represents me correctly. I would like us to move to a world where the first nibble actually is a demux point, and I'd like for us to be able to use that independently of other signaling mechanisms. Therefore, I recommend that we allocate a code point for M&A.
Okay, Joel, you have
I
something to...
actually slightly disagree with Stuart because, and well, I strongly disagree with Tony. I don't think. Well, let me. I'll come back to that part. Given if we assume that we have an indicator in the stack or in control of the presence of post-stack data, if we decide we need a nuanced post-stack data prime, we can put a second indicator in that says, oh, actually what's there is post-stack data prime, so we don't need to rely even for that on the use of first nibble. I would prefer not to rely on first nibble because it's small and overloaded and error prone. I will grant that if you assume control, there is control that tells all of the relevant parties that there is post-stack data. And if you need post-stack data, then you could dive down and find it that way. But even if you're doing so, you don't need the first nibble to verify it. Control has told you what's present. If it doesn't parse right, it doesn't parse right. But if control tells you, you parse what you find. So I don't think even for Tony's use case, which I'm still not convinced of, but it can be made to work. Even for that use case, we don't need an actual demux point on the first nibble.
Stewart, you're back.
There's a huge delay from mute, sorry. So I guess I'm a bit more conservative than Joel is on this, because there may be a case when you're, for example, instrumenting the stack side of the system where you would like an indicator that's not part of the stack. So try to test whether your sort of stack parameters work. And I don't have a case. I am just trying to make sure that I could build it if I wanted to, because I got tripped up by this once before. A question for Tony. What would you do if in your world, if that P router had a pseudo wire packet without a control word passed through it, and it had the quotes, wrong quotes value as the address, such that the first nibble meant something to your router?
I'm not sure I understand exactly the use case, Stuart. It would seem to me that that interesting case would only occur if it's the exit router. And if it's the wrong nibble, then I think the router would be very confused as to what to do.
Well, not necessarily. Let's just explore this a bit. So I was interested in the P router case, right? Because sometimes it would appear that that some people would like to do stuff in the middle of the path. So you're an innocent P router, and someone is sending pseudo wire traffic through you. Well, so someone is sending M&A information through you, and you're handling that just fine. You've been taught about that, and then someone sends you a pseudo wire packet without a control word, so it looks like an MPLS label stack, which you're trying to skip checking, remember, an MPLS label stack, and the first nibble is whatever the first nibble of the Ethernet address was. So and if that alias is the first nibble that you're using to trigger functionality, what happens?
Again, I don't understand the use case. If you're doing M&A with only PSD, then I would hope that the P router doesn't even have to look at it. So I don't think that it's relevant.
Oh, right. Okay. Well, we can make it. We can define it to be irrelevant to be not relevant by defining out of scope the case where a P router looks at the post stack data. We can say that that is not an allowed case. That would resolve the issue in that no P router would ever be looking for M&A information below the bottom of stack. But once you get to the edge node, why wouldn't you have a service label there? Normally you'd have a service label, and once you've got the service label, you've got all the context you needed anyway.
And if we want to use M&A, then we have to have ISD.
Sorry, I didn't understand that one. Say it again.
So if you wanted to encode M&A PSD,
Yes.
then you're again arguing that we have to have ISD.
I'm arguing you have to have something in the stack to tell you how you handle this packet.
And I was trying to avoid using that bandwidth, so having a code point would tell us what was in the packet.
Not necessarily. The same route, supposing the same edge router was also doing pseudo wires. If it's not got any stack information to help it out, and it was doing pseudo wires, well, I suppose it would have the pseudo wire tell it what to do. So you're trying to make a special case for this on the basis that everyone else needs a service label.
I'm trying to have a code point so that we don't have to have service labels all over the place.
I need to think through whether you're going to be the unique exception with this in the entire sort of internet, or whether we really do need service labels as part of the MPLS model.
I'm trying to walk away from heuristics and have a defined code point.
With a service label.
Yeah. Loa, you're next in the queue.
So much as I actually sympathize with what Tony is saying, it would be neat, though it actually means that they have to deprecate the Ethernet pseudo-wire without a control word. And we've been over that, and actually we couldn't do it at that time. So I don't think that's the way forward.
Joel?
Thank you. I think Stuart was getting at what I was thinking of, because I've been trying to understand what Tony is assuming. And I finally realized that he was assuming a combination of things, namely that there was control information to tell you you will sometimes receive post-stack data without a label stack, without any indication in the label stack. And the way you will tell that this particular packet falls into that control is by looking at that first nibble. Given that first nibbles are not reliable and just waving our hands and pretending they are won't work, I can't make that work. Whereas if it's either a service label or an overloaded pseudo wire label, or an overloaded or a multi-valued end label, so you do use different end values to indicate different behaviors, then you don't care what the nibble is, because you have other ways to tell what you're supposed to be doing. And I think that's actually far more robust.
Okay. All right. It's my turn now. So my comment is, I could signal with the service label, please look into the nibble to find out what to do with it. So basically, only when when you get the service label X, and you're allowed to look at the first nibble. So that could eliminate the concern about an Ethernet packet coming in, and we peeking at the nibble all the time. So that was one point I wanted to raise. Thank you, and I'll pass it on to Jimmy.
Can you hear me now?
Yes.
Okay. So my understanding is we have clear specification about the egress node to use a service label or some other context label to together with the first nibble to determine the context and the content of the following data. Well, we don't, but so far we don't have any specification about how the transit nodes to use the first nibble to determine the content of the payload and other data. So do we need one about that? Before that, before that we cannot maybe make the decision about how the transit node to use the first nibble, or whether we still rely on something in the label stack.
So, shall I go?
Okay.
To answer G's question, the only way I can think that would work reliably for an P router to know that there was post-stack data would be that there was an MNA label, and that context was provided through the MNA label. I don't think anything else would be safe at all. In terms of our previous effort of deprecating Ethernet pseudo wires without the control word, the group of vendors that found it most difficult and objected were vendors who were in the transport network business. Not the transport layer, but the transport network. And they were in the business of using MPLS to provide the transport network, and their equipment was incredibly primitive, really simple, tiny number of functions, not a full-blown router at all, and they did not have at the time, so it was communicated to us, the capability of doing anything cleverer than what they were already doing. So. And the thing about transport networks is that they can be in place for a very long time. As speeds go up, the equipment tends to be moved to other duties. So I honestly don't know when we're going to get rid of the Ethernet pseudo wires without control words. And back to the chair.
Yep. We don't have anyone in the queue. Let me just join in and say, okay, so we discussed two mechanisms, one for P router and one for PE router, or potentially two, one for P and one for PE, for finding what's in PSD for MNA. Do we need to unify? Maybe they don't need to be unified. The mechanisms for a P router to deterministically know could be different from the PE. Thanks. And Stuart, you're next.
I'm just wondering whether the right way forward here, because I don't think we're going to get an agreement on this call, and an agreement on this call would have to be followed up on the list anyway. I'm wondering whether we should craft a set of questions for the MPLS list to see what people's sort of preference for these three solutions would be, with some text, of course, explaining what we've learned on this call today about the nuances of the various approaches.
Okay, Joel, you're next.
Tarek, while I understand why you made the suggestion you did, having two different methods for representing the presence of post-hoc data seems an invitation to trouble. And I really hope we can avoid doing that.
Thank you. Okay. I don't see any further hands in the queue or anybody trying to get into the queue. I could go back to the agenda. The suggestion, Stuart, is a valid suggestion. We can take it back to the chair's meeting and discuss it. So it's a sound suggestion. Okay, I'll move on to the next topic then. So last time we asked if there were use cases.
Wait.
Yes, Laura.
I didn't catch what you said about Stuart's proposal. Did we make a commitment to discuss it among the chairs or what?
That's what I didn't commit to making it, but I said we will discuss it in the chairs meeting.
Okay, thanks.
We should discuss it, but whether the question is asked on the list as chairs or whether it's asked as an individual contributor is also for discussion at that meeting. I don't know whether it's our business to do that or not, but I do think the question should be put to the list so that we can get wider input.
That's right. So we will discuss that proposal. Okay. So today we have a use case that Rakesh had presented in the past, but we will bring it forward again. It makes use of PSD, so I'll share his slides in 10 seconds. I'll have to switch slides, so give me a moment. Okay, Rakesh, it's on to you. I'll give you control.
Morning,
Yeah, go ahead.
am I able to?
Oh, I lost the
slides. I lost the slides. Or is it?
I was trying to give you control, then I gave full control. How about now? Do you see them?
Yeah, I see them.
Okay, you should be able to flip between slides as well. But let me know if it doesn't work.
Yeah, I don't see how to. Maybe that's okay. Okay, because I had requested. Maybe I can switch it now.
Can you try again, please, Rakesh? You requested something, you said?
Yeah, I requested us to share slides, so I'm asking.
Okay, how about now?
Yeah, perfect. Yeah, it
Okay.
works now. Perfect.
Thank you.
So good morning, good evening, everyone. My name is Rakesh Gandhi. So this is one use case, the in situ OEM. And I think the chairs were looking for some use cases that can the PSD can benefit. IOM definitely is one, but I took a step back a little bit and even go to the basics and say that we're trying to do telemetry. You have controller, you have collectors. You're collecting some data from the network to do kind of analytics and whatnot. And this is where
you will see a lot of this in situ OEM coming into the picture. So just to step back a little bit and look at the telemetry aspects, I have just a few slides, and then maybe we have some discussion around this topic. So this is what the chair's looking for: ISD, PSD. What are the use cases? How can you do it? Pros, cons, and whatnot. And I thought maybe going back to the telemetry might give some more context. So as I was saying, we have a network, we have a collector and controller, and the goal is to collect the data of a specific traffic flow or flows in the network. One simple idea that's proposed in one draft song is that it's a flag-based option, right? So you have in-stack M&A, and you just have a flag, and the flag is set. It triggers on the node to say that trigger the telemetry. Now it's a local policy on what data to be sent to the collector. It could be the incoming interface, outgoing interface, incoming timestamp, the node queue information, whatever is provisioned. But the packet is lightweight because only carrying a flag. So it doesn't bloat your stack. It's just a basic M&A. So this is one use case. The way this works is that all the nodes that process this M&A will generate the telemetry data and send it. So it's up to the collector to reconcile the data, because it comes for a specific flow from different nodes in the network, and it has to put the whole flow together and do whatever analytics that's doing. So this is one solution, one draft that talks about this way of doing stuff, and because just a flag, it makes sense to just put it in ISD. I see Greg in line. I don't know if I go through all the cases and then we discuss, or we can go each one individually. I'm fine either way. I only have four cases to go through.
I can hold that thought. Thank you.
Okay, good.
Okay. So just a flag-based option. The second one that's proposed in draft CX for M&A is again in stack option. It's a little bit more information than the previous option. In this case, it's an alternate marking. So you have two flags. One is flag for the delay, one for latency. And you have flow identifiers. It makes a controller's life easier because you have a flow. So if you want to reconcile the data coming from all the P nodes or P nodes in the network for a flow, you have flow ID. So you make the controller life easier. Again, what data to be exported via telemetry, it could be based on local policy. And again, it's a simple, put it in ISD, things don't change, it's quite static. And this is one proposal. And now we go into the some of the work that IPPM working group has done, defining. There are two RFCs for it. RFC 9326 contains the direct export TLV kind of information, and it's carried in the packet. It has more things than the previous two options. So you obviously they have defined flow ID, but there are basic fields, and then there are optional fields that you can put on top of it. Again, this is also you would do direct export if you're doing hop by hop. I mean, you can do end to end as well, but let's say if you're doing hop by hop, then all nodes will send this telemetry information to the collector. One good thing about this direct export is that what information is sent is maybe it's based on local policy, but it also has a set of flags. So it says that send this, send that, send that. So it's kind of give a guidance to the node to say send this kind of information because that's the use case and that's what I'm looking for. And I need queue that, for example, from all of you guys. So it makes it more explicit as a request, and then obviously everybody will send it, but the cons is that you're carrying information in the packet. So the IOM has defined, this is an example I copied from the RFC 9326. So it has IOM has a namespace, flags. These are the flags that I was talking about. And then various flow ID, sequence number. There is a new draft to do extensions to say also let's carry the timestamp as well, and it can grow. So you had two LSCs as mandatory, the first two, and then you have optional, which can grow. So that's basically the IOAM way of doing the telemetry using direct export. Again, it's done by each node, as I show in this figure, and the collector reconciles information. And the fourth and last option in the telemetry, and again, there might be some other options. This is not the exhaustive list, but these are some of the drafts that we have in M&A, and there might be more drafts as well. But in this particular option, idea is that the information is collected in the fixed header from on each node, and it goes to the egress PE. So there is no need to do telemetry from each P node. They just kind of stamp the packet with whatever information is needed. Could be timestamp as requested, or it could be interface ID or whatever that might be, if it's hop by hop. And then it goes to the egress PE, and egress PE will digest it or do telemetry, and done with it. So this is a different option. It's a recording option where P nodes no need to do telemetry. The collector doesn't need to reconcile all that information, because it's all the PE node, egress PE node would have everything that you need. So the way IOM RFC 9197, they have defined again the option type, just like direct export. So you have namespace and trace type and whatnot, and say this is a pre-allocated. So pre-allocated means you have fixed buffer in the scratch pad in the packet itself that everybody writes, and incremental means that everybody will add their information append to it. So if it's a 10 hops, then you will see that 10 nodes, and then in each hop on the right side, you will see node ID or interface ID, timestamp, all kinds of stuff. And there are a whole bunch of trace types defined, and depending on what gets enabled, you allocate that much of space and you build upon it. So again, you can see that with so many options and stuff, you could end up, depending on how many hops the packet takes, you can end up with large amount of data that's carried in the packet. I mean, this one looks, more like PSD solution. So those are the four things I see as telemetry. Some of these solutions, we have drafts for them. Some things to consider is that the amount of telemetry data that needs to be processed based on how many is it coming from your entire network, all the P and PE nodes, or only some PE nodes. And what is the size of LSE? If you put everything in the stack, can the NCAP node put that big into the label stack, or how do you implement it? I think that option 1 and 2 seems like ISD options for telemetry. Option 3 and 4, if you're going to have a large amount of data that can grow its variable, maybe it's for PSD. So this is just the suggestions. And now going back to the questions there was raised, any use case motivating PSD. So for example, hop by hop recording, probably a good option for PSD. It's very, I don't know if it's ISD, you can do it, amount of data is large, and you're changing the label stack with timestamp and whatnot along the way. Because amount of data is large, I don't know, it's really ISD use case. Is it urgent, or I say it's a one good solution for it. if you're going to work on it, that's a good solution. Impact on compatibility issue. I think the first nibble is really for the PSD. It would be a issue related to the compatibility. And that's all I had on this topic. The rest is just going into the protocol extensions and stuff about IOM, but it's already in the draft. It was presented before. So unless there is a specific question, we don't need to go through the rest of the slides. Thanks.
Okay. Thank you, Rakesh. Greg has been waiting in the queue, and go ahead now, Greg.
So if we can rewind to, let's say, use case 1.
Yeah.
So I'm not sure how this envisioned to be applied, but it has some similarity with one flag alternate marking method. In fact, alternate marking method can use either one bit flag or 2 bits. The 2-bit provides more accurate latency measurement, but effectively even 1 bit can provide good packet loss and alternate marking method. Furthermore, there have been documented how to use 1 bit for sufficiently accurate delay measurement. Yes, local policy can define what additional operational state information to be collected. But in MPLS, when we first discussed alternate marking method, it was decided to use what's called synonymous flow label. And that already, as I understand, these documents are progressing. So why not to take a look and see whether this known technology can be used without any additional load on the label stack. Further, what I would point is that, yes, direct sending operational state and telemetry information to a collector from each node is one option. There is a proposal in IPPM working group. It's called hybrid 2-step, which explains how a packet that carries operational state and telemetry information can be carried along the same path as a trigger packet and then arrive to the terminating node. So thus all the information is collected and that simplifies the correlation by the collector. So that alternative option of collecting out-of-band telemetry information. Because as I noted in our previous meeting, telemetry and operational state information are valuable, but putting them in band with data is prohibitive for DetNet, because the DetNet paradigm is that resources allocated so that OAM does not disturb in a normal condition the data traffic, because the purpose of DetNet is minimizing packet loss, providing bounded packet reordering, and very low latency and jitter for packets. So it seems that loading in a data plane telemetry information, operational state information will definitely change the economics for the DetNet, because these resources will have to be guaranteed and reserved. So in that sense, separating generating telemetry information and its collection using the management plane out of band for collection seems to be more viable, at least for DetNet. So actually my note about the way how information can be collected from transit nodes, so it's applicable to all the scenarios here. But what I really don't understand is why cases 3 and 4 are put together and positioned as same solution. Because in my opinion, advantage of direct export IAM is that it's a limited impact. So their addition to the stack is limited, while provides the flexibility and richness of operational state and telemetry information, with opportunity of centralized, or at least from the orchestrator, to define what type of information to be collected. So you rightfully pointed out that the type of information in two models is more local policy, but with the IAM already defining its flags, so it could be done from the orchestrator, so which seems to be a better model, less chance for human error misconfiguration. But another benefit of direct export, as you point out, is that this information is collected out of band. And whether it's each node sends it directly to the collector, or some other method, as I mentioned, the hybrid two-step is used to collect along the path out of band, and then so thus simplifying correlation of telemetry for a given flow. That's a orthogonal issue. But I see that direct export IAM is suitable for in-stack M&A. Thank you.
Yeah, thanks, Greg.
Tony, you're next. Tony, if you are muted, go ahead and unmute yourself. We still can't hear you. No, it's not working.
Hello.
Yeah, I can hear you now.
Hey. Thank you. Sorry about that. Meet Echo seems recalcitrant to let me unmute.
Okay.
First off, I didn't see any citation to Greg's IOM DEX draft. That seems like an egregious omission, as you seem to be trying to do a literature survey here, and how you missed that, I don't understand. The key point I think that you're trying to make here is that there is a use case for PSD because of hop-by-hop recording, and I would have to take issue with that. Hop-by-hop recording is not a practical way of moving forward. It causes the packet to grow every single hop. And all practical networks have a finite MTU at some point, so you're guaranteed to fail at some point. So, I don't think that that's a very good argument.
Loa?
So, Rakesh, can you go to, I think it was slide 9. Yes, I think it was this one. So on the right-hand side of the picture, this is what every node actually adds to the pre-allocated space. Is that right?
So IOM defines two options. So one is pre-allocated and another one is incremental trace option. In pre-allocated, the NCAP node has puts the scratch pad in the packet. So this way the packet doesn't grow as it travels the path. In case of incremental option that's defined, each node will append its data, so packet would grow. So these are the two options that's defined.
So understood. So staying with the pre-allocated, so you say that there are 4 times 32 bits added by each node. Is that right?
So this is one example of a data list. There are many different encodings, and it's based on the flags. So it could only be, for example, hop limit, node ID, interface ID, and egress interface ID. Only 2 LSE, could be 3, could be 4, or different combination of it. There's queue length and stuff, and it's based on there is a bit flag that defines what OEM data to be collected or carried in the packet.
So what I was kind of going to say is that if we have a case where you need to add 4 LSEs for each node on the path, then even if you do pre-allocated, you can't put it in stack. It actually grows too big anyway, so you can't have it. We discussed it in some other context, and I thought I heard that 5 LSE is what we can live with in stack, and we can't go more than that. So this is already here out of scope. The thing that the argument that the packet grows is not correct if you do pre-allocated. That's right, isn't it? Rakesh?
Maybe I missed that, Loa.
What I'm saying is that if you do pre-allocated, then the packet will stay the same size across the network.
Right. Yeah, absolutely. Yeah.
Yeah, okay, fine.
Yeah.
I had something more, but I've forgotten it. Okay, thanks.
And that's also the option that IPv6 is going ahead with. So they mentioned last time that IPv6 would be supporting a pre-allocated trace option, and they would not be supporting incremental trace option.
Okay, it's my turn now, Rakesh. Can you please go back to the slide where you're showing the nodes exporting data, metadata, to the collector? I think this use case. Right, this would work. This would work. So this is closest to direct export method. What you're trying to show here is you enable the flow, enables the telemetry using some mechanism in stack, and the OEM data gets streamed in telemetry to the collector. One advantage, I mean, the in-band collection of OEM data does not require at least all P nodes and possibly the PE node, the ingress node. It doesn't require the ingress and all P nodes to export or stream telemetry, or even contact the collector. In that case, only the egress is doing that. correct? So the egress will be exporting the data.
Depending on the scope, so if the scope is defined for M&A as hop by hop, then each hop will process M&A, and then if they support the telemetry action, they would export it.
No, I meant it's recorded hop by hop in band, but then the packet, reaches the egress. So I'm talking about in band OEM, not direct export.
Yeah. Then right. So in that case, everybody records in band, and then only the PE node would take care of the telemetry.
So that's an
Right.
advantage I see, that some nodes might, some P nodes, if you have a large network, over the direct export method, is they don't need to export this telemetry data. Thank you.
Yeah.
Okay, Tony, you're next in the queue.
So I disagree with what Loa had to say about pre-allocated somehow fixing the problem. It doesn't. Pre-allocating a kilobyte of data and sticking it on the front of the packet does not change the MTU problem one bit. It only changes where the packet gets dropped. So pre-allocating tons of space is not a good solution.
Loa?
That would be true if that's what I said, but I just commented on the difference between incremental and pre-allocated, and I said that pre-allocated does not make the packet grow. Then you have to make sure that you actually pre-allocate a reasonable amount of data for the post stack. And looking at the picture here, if we are going to add 4 times 32 bits per node, that number is rather low. Thanks.
Tony, if I can answer your question.
Please.
Before he asks?
Yeah. So there is, I know of a solution which has each node adds 3 bytes of data and allocates 48 bytes into the scratchpad, and it supports 13 hops. So with 48 bytes, 3 bytes per hop, plus the header, the top header, you get it for 48 bytes. Thanks.
Tony?
That's not enough. 13 hops is not enough. What's the diameter of the internet?
So I gave an example of the numbers, but there is no. It's you can, if you know the path of the packet, you can configure it however it to be. But it's not 1K. We're talking about for 13 hops, 48 bytes. I mean, you can do the math, right?
I can do the math, and the math says that putting this in the packet doesn't make a lot of sense when we could just be doing postcards.
Well, you're in the queue.
Hello? Can you hear me?
Yeah.
Hello? Oh, okay.
I can hear you. Go ahead.
Yeah, I think, for the pre-allocate mode of the IOM, it indeed increase the packet size. But I think any protocol that change the packet size will face a similar MTU problem or concern. Even for the MPLS, you add this new MPLS label stack to the packet. It also increase the packet size. So I think it's totally depend on the application. When the ingress node decide to allocate some space for data collection, it must takes this into consideration. If it can actually fit in the packets without causing the MTU problem, then this similar issue is faced by any place this IOM is applied. So that's not unique to MPLS. And in many use cases, I think the user, depending on the scale, the length of the LSP, and depending on the what kind of data the user really want to collect, the size is, I think it's under control. It's not a lot of it. So in this case, the IOM trace mode can be applied. Thank you.
Okay, Stewart.
So I think, Tony, with respect, using the diameter of the internet as an example here is what's well known is not actually relevant, because MPLS is usually deployed in a limited domain, and normally you would know the size of the LSP or the expected length of the LSP. I would imagine that any sensible protocol would have a mechanism for dealing with the case of when the predicted size was exceeded, that it took a defined action, drop the packet, stop recording it and make a note, or something else. But I don't think we can use the diameter of the internet as an example here. Thank you.
Greg, you're next.
Okay, so one point on comparing usefulness of writing data in a packet, in a trigger packet, and collecting information out of band. As I think that we discussed, so separating processing the data packet with writing into it allows for more accurate latency measurement, because it's suggested, point out that accuracy improves if timestamp or wall clock value is read at the same moment. The problem with storing the timestamp in a trigger packet, in a trigger data packet, is that the packet needs to be processed after the value is read. So thus there is some queuing delay, which adds on jitter and affects the accuracy of the measurement. So that's another argument for doing the collection of information out of band separate from the packet. At the same time, again, what IPv6 agreed to do with encoding of IAM does not, in my opinion, means that they realize their impact on extension headers that might be coming with the pre-allocated trace option in IAM. So they might be for a big surprise. Will be interesting to see how IPv6 how network operators will react to these packets coming their way. Thank you.
Okay,
Thank
Tony.
you. So let's see, several points. First off, the application that I work on is called the Internet, and we have an MTU because people actually want to send data. And most of the time they want to send a lot of data, and most of the time they want to use the MTU. That means that they want to send, max MTU packets a lot of the time. And we don't have good protocols for figuring out what the MTU is. And the world kind of breaks badly when the MTU changes. So for us to suddenly slap on lots of extra bytes is not a good thing. We're taking it out of customer payload. Okay, this is going to cause major problems. Not a good thing. Second of all, the diameter of the internet is very much a function of the diameter of our service providers. And as all the vendors on here will gladly attest, there are many of our tier 1 customers who have a diameter of their network, which is a significant chunk of the diameter of the internet. It's traversing entire large networks using MPLS, and they're getting many, many, many hops. Okay, 13 hops is not enough to transit some of the networks that I know about, and I'm sure you do too. So pre-allocating a whole lot of data is really, really not a great idea.
I acknowledge Tony's rebuttal of my point. Yes, you're right about both, and of course it is the customer that owns the MTU rather than the well, obviously the service provider owns it, but the service provider needs to provide the customer with the biggest MTU they can because they want to send real data and fewer packets. So yeah, I largely agree with you, Tony.
Rakesh? Yeah, so basically, idea is that when we talk about the overhead, it was a 3 bytes per node. So, I mean, if you have 25 nodes, then you do 25 times, 375 plus you add, 8 more bytes of the header. So that's the math. It's definitely not huge, but again, you had to, the service provider owns the network and has an idea about what's really happening, and there are other mechanisms. If you are you have limitations, you would stop recording it, or you do recycle the packet. The recycle the scratch pad and you overwrite it. So there are other means of it as well. And I just wanted to step back a little bit about the first 3 use cases about they are related to sending the telemetry data about P node to the controller. So the first one is simple in the sense that it only has a flag and it's up to the, there are 2 things that's missing in the first one. It's missing the flow information, so it makes the collector's job harder. And it doesn't have information, so you had to provision on each node what information to be sent. So this is that's solved by the number 2, where you put the flow ID, and now it makes the collector's job easier, but still has to process information from all the nodes. Now, if we say that I don't want to provision all the nodes, then there might be a way to say differently. We don't have to use IOAM option, all the trace namespace and flags and extensions and all of these things. I mean, you could define a bit of flags in the MNA itself to say that I want to, and I think there are only a handful of stuff that you really care about, right? Interface ID, timestamp, or node ID, or whatever, 4 or 5 things. So you don't need to go through this extent of using the whole IOM direct export with so many LSCs and this and that. You could just define and say that I'm not going to provision every single P node in my network, but my packet will have a bit flag in the MNA that will say just export this piece of information. So just looking at the problem, see what is it that we need for telemetry, what are the issues, and then solving it in a more efficient way is probably could be a good way to make progress. Thanks.
Thanks, Rakesh. I just want to give a heads up that we still have 30 minutes for the meeting. We're 1 hour and a half through. So I'll make, if we want to discuss the last items on the agenda, we can go quicker on this discussion, but it's a very good discussion we're having now, so I hate to stop it. Greg, you're next.
It's not clear what information is collected in this 3 byte per transit node. I would guess that it does not include any latency-related information, because literally the timestamp is, I remember, it takes 4 long words, so it's clearly far beyond the bound. But again, I'm not questioning that in some environments where bandwidth is plentiful, it's feasible to put any amount of telemetry information in a data packet. But I don't see it a good reason to do it everywhere. So if somebody wants to do it, it's their network, yes, certainly. On a point of challenge to correlate information, I already mentioned that there is a proposal in IPTM working group on hybrid two-step mechanism protocol that allows collection of state and telemetry information generated by the data packet, and then transporting it as train of packets, sequence of packets to the end node. So thus lifting this problem from the collector node. So if there is interest, I can prepare some presentation for the future meeting on what hybrid two-step is and how it envisioned to operate. Thank you.
Okay, I think I'm going to be quick. It's a suggestion to Rakesh and the authors of IOEM in band. Did you, for large number of hop LSPs, did you consider breaking down the scope of testing or recording to segments of the path? Basically, if you're traversing 20 hops, break it down to 10, and then export the metadata or the collected data, and then record the next 10. Just an idea, and I'm not sure if that was considered.
I can comment. Yeah. So it is considered, and it's definitely a good way to solve the problem. Thanks.
Okay, thanks, Rakesh. All right. I do want to go back, so I don't see anybody else in the queue, and we can go back safely to the agenda. But you're sharing, so I'll take back the control. Can you stop sharing on your side, Rakesh?
Find how to do it.
Yeah, I'm also finding it difficult.
To share screen. So
it's okay. I took care. No problem. Okay, so we still have 2 items, but we don't have too much time. I think item 6 was a call for further input on the PSD discussion. We've been having this discussion all along, but let's see. Do you want to add anything to this, Loa?
No, item number 6 is just an announcement or request that we need to have more of these types of discussions. So people that have things that they want to discuss and combine with answering the questions should do so and request slots for the ITRM meetings when they are ready to go. Thanks.
Okay. All right. I will lower your hand. And the last item, or actually before the last 7, Stuart, you've asked the talk about that email, it's your chance now.
Okay, so it was really a simple and possibly naive question. I was just we're talking about putting information in the stack ISD, and we may need to write that information. For example, no further fast read route is a good example. I was just making sure in my mind that we could actually write into the stack, and the reason for, in other words, overwrite into the stack. And the reason for asking is to make sure that the stack is actually a read-write cache rather than just a read cache, because I could see some implementations might implement the MPLS stack as essentially a read cache, because most of the time you never need to look at anything other than the top, other than the label after the ones that you've popped. So I'm just making sure that we're not going to fall foul of implementations that can't actually write ISD into the stack in prearranged places.
Okay, I guess Tony, you can go.
Stuart, I'm sorry, we're always going to fall afoul of implementations that do unfortunate things. This is just the fact of life. We don't control what people are going to do, and they don't know about the future. So the way that ISD draft is written, it's pretty careful. We try not to make anything that is basically in the first label of the LSE. None of that is writable. Because there are going to be implementations that are going to hash that for entropy purposes. So we want to avoid writing there. The remainder of the LSE is writable, and there's no question about that. And if an implementation wants to support M&A and wants to support a function that actually wants to write in ISD, then it needs to figure out how to do that.
I was just trying to understand what the world looked like and whether the majority could do this, or whether there was any significant minority that couldn't, or indeed any minority that was going to object. So I was just trying to understand what the lie of the land was. I don't know what the scope of it, what implementations can or can't do in terms of writing, overwriting labels that are in the stack, but not at the top.
Okay. The last words you said maybe will negate what I say, or maybe not. So I'm aware about an application in segment routing where the packet comes in with a top label. Maybe it's a binding label, binding SID, and then it expands the label stack. It grows. For example, they replace one label with several. But that's always manipulation of the top label. In that case, that's what so you can consider it as a write, but yeah.
No, they don't worry. I think those are well known and likely to be around, and a lot of that is all done in terms of pointers to build the packet. So basically, you have a pointer to the thing that's going to remain. You have a pointer to the stuff you want to add in, etc. And you say, "Hey, DMA engines, just go and get on with this when the packet goes out." That is a sort of well-known sort of fundamental characteristic of a number of implementations. But what we want to do is maybe have M&A not at the top of stack, and we may wish to change a bit. And I was really asking the question whether this is widely allowed, because or whether it is widely denied. And the reason for asking is that so far, anything other than the very top of stack could be read-only cache. And I was just trying to understand what the state of the world was before we made too many assumptions.
Thanks. Greg, you're next.
I think that I have in mind one of their use case for the functionality that Stuart is inquiring about. So imagine that we want to have a bounded latency and some budget is provisioned to the system, and so that thus the transit nodes will be obviously decrementing, reflecting their residence time packet being in the system. So by decrementing this budget. So that's if we run out of time, the packet might be dropped altogether rather than being, taking more resources in the network. So that's might be.
Completely agree with that use case. Completely agree with that use case. So my question was solely to do with, are we confident that the hardware engineers are not going to shout at us? I think it's how you stand.
Yeah, it's how are you right now? Yeah, go ahead, please.
Hello. Yeah.
Yeah.
I remember I pointed out another issue about this writable data. A long time ago, we want to support ISD. Is one reason for that is it's because it's more reachable. It's closer to the top of a stack. Then, in case there are actually the label stack is very deep, then the ingress node has to put multiple copies of ISD in a different place of the label stack in order, because at some points this will be popped out, and after that the next copy in the label stack can be accessed. So if this is supported, then this writable data is really dubious, because if it's a written change modified in the on the path, then only the top SD will can be modified. All the others are not. Then you will lose the synchronization between all these copies. So that's a big problem.
Yeah, that's a good point, actually. Yeah, it's a very good point. I mean, we would need rules for propagation of values and which ones could be propagated and which ones couldn't. But yes, that's also a good point, the synchronization of the data. But I was simply dealing with NFRR, for example, as an example of one where it's a very simple write, and I'm just making sure we can. And it's really a question for our hardware teams.
Indeed. I think there is a homework that can be done here. How does that translate to our working group? Maybe a poll would be an option, or next time we meet, we can get some feedback. But we can discuss the options if you like.
I am just sort of, it just occurred to me the other day to ask the question, and I'm asking the question. And I'm asking the question because it would be really unfortunate if we specified something and then discovered that the overwhelming majority couldn't do it, in which case the functionality would probably die very quickly.
Okay. One question from me, Stuart, is we discussed that the actions, most actions, I know you're given an example of no further fast reroute, which is enabled on the point of local repair node. But we discussed most actions will be set by the ingress, and those, and then besides I mean, given that we have a discussion of PSD data being manipulated if we need to, So there are handful numbers of use cases that will be impacted, right? Not many.
Yeah. Well, I mean, there would be that one. There would be the one that Greg came up with, which is one that I forgot about, but actually has been quite close to the top of my mind with some of the 5G latency stuff I've looked at.
Okay, I see.
Yeah. So there are a number of use cases, and we just need to be clear whether we are, pushing on an open door because all the hardware can do it, or whether there's an elephant sitting in the corner that hasn't roared yet.
Right.
Yep,
In most cases,
being rude.
in the requirements draft, sorry, I was going to, if you remember in the requirements draft, did we come across a transit node being able to insert M&A label?
This wasn't insert.
Okay,
Neither
modify.
Greg nor I were talking about insert. We were talking about modify.
Okay. So modify an existing M&A. Okay.
Yeah. Well, modify. I mean, well, NFRR is a potential case of modify, and certainly latency time consumed is an example of modify.
So yeah, it could be insert though, NFRR and FRR, right? It could be an insert of M&A if it wasn't there as well.
If there was no M&A, if there was no M&A there, there already was an M&A.
Right? Did we negate inserting having multiple M&As in the stack?
I don't know. I'm just making sure that we know that we either rule out this as not needed and forever live without it, or that we're absolutely happy that it's viable and we carry on with it.
Okay, got it.
Okay. Well, I think maybe it would be useful, I think, if those people who still have attachment to hardware teams were to ask their hardware teams whether these sorts of things are feasible, or whether they are, i.e., to modify a field within the label stack, not at the top of the label stack, whether those things are feasible or whether they are a showstopper for their design.
Okay. Yeah, I will record that as an action item at the moment, Stuart.
Yep.
We can definitely revisit that. Jagan, you go ahead if we still have 5 minutes. So yeah, go ahead.
Yeah. Hey, Shiva, actually, this is regarding your previous question. So are you asking that can the hardware change any of the existing information in the label stack?
Stuart, do you want to answer?
I'm muted. Hang on. I'm muted. I'm muting myself again. So yes, what I'm saying is that supposing we have an M&A in-stack data system, are we able to modify a value within that data block? Should that be necessary, or does the hardware would the hardware find that very difficult? And it's all to do with the caching behavior related to how the stack is handled.
Okay, because today in SRv6 cases, right? So we update the SRH headers. So we update on the fly, right? So isn't it the same thing with respect to the general hardware perspective?
Well, you do for IPv6, but I don't think you do for I don't think you modify anything for MPLS, do you? It's push and pop only.
That's right. Like I'm saying that like as a general hardware capability, right? So we do that for SRv6, just changing the some of the information in the stack.
Yes, absolutely, and we probably can do it, but it would be well to find out whether there's anything special about MPLS. I mean, particularly, the sort of routers that would find this hard are highly optimized service provider cell phone edge sort of things, which are built to a budget and can't really do very much, and yet might need this instrumentation. And it's all a question of how fundamental this change would be for such routers. I don't know. Maybe I am just worrying about nothing, but better to worry about it than have a surprise later.
Okay, yeah, thanks.
But it's the cheap routers that I'm worried about.
Okay.
I know the expensive ones can do it.
Okay. I will record the action item as I'm. Oh,
I think
okay.
Tony wants to respond.
Yeah, we'll give him a chance. I think it's the last 2 minutes now. Go ahead, Tony. Okay, we're not hearing you. If you're hearing us.
Hello, can you hear me now?
Yes.
We can.
Okay, we need to file a bug with Meet Echo. So the cheap routers are not the problem. They are system on chip. They're basically a CPU dealing with memory. They have full write access to the packet. That's never the issue. It is the hardware optimized routers that are the question.
Yeah. Okay.
And I can't speak to current hardware, but at least 20 years ago, this was not a significant issue.
Okay, was he audible for everyone or just me?
Yes.
breaking up?
Tony was saying that it's not a problem for the cheap routers because they are essentially conventional rewrite systems, and the issue is hardware optimized routers. And his recollection of 20 years ago is that this wasn't a problem. I still sort of pose the question as to whether anyone has sort of taken any functionality away and not told us. And maybe I'm worrying over nothing. Maybe this is, it's really just a coffee corner discussion with the hardware teams, just to make sure that they aren't going to go freak out when they hear that this might have to be done. And I can't do that myself. Okay.
No, I think we talked about a call of action kind of for everyone who has access to hardware, to get some feedback. Now, how does that materialize? Either next time we meet, we get the feedback, or I think the options are a poll, or maybe someone will reply to your email, I guess, Stuart. I want to say that we're running out of time, and we're actually out of time. And Loa, last chance to...
No, I just going to tell you that we were out of time. So we need... Meet Echo closes down within, I think, 5 minutes. So we need to finish up now.
Yeah, I am planning to close it. So thanks again, everyone who joined. For next time, if someone has any request for slots, please do send the requests as early as you can, so that we can discuss it in the chairs meeting and decide if a meeting is needed next week. That's it.
Okay, thank you.
All right, thank you so much. See you next week if we meet.
Okay, bye-bye.
Thank you, everyone. Talk to you soon.
Bye.